Just wanted to go through enlargements quickly with you. I'm not going to do too many examples. It's a bit tricky to set up. If I can't use paper and stuff. So, but we'll see how we get on. I think it's pretty straightforward enlargement. Students generally can trip up on it quite easily, but I reckon if you follow these steps, you'll be fine. So, first of all, if you remember from last week, we call the original shape the object, okay? And then after we transform it, it's called an image. So if you think of looking in the mirror, you're the object and the reflection is the image. So, and usually they'll give it a letter like A and they'll say enlarge it such and such. And SF, we like to simplify scale factor to SF. So if you're looking at a scale factor, I didn't want it in red, scale factor of 2, surprise, surprise, you're going to double each of the sides. And then we might call that A with apostrophe to suggest it's the image of A, or we might call it B, depending on what the question asks for. I've no doubt you can imagine scale factor 3 would be 3 times the size. Good one. A apostrophe apostrophe. Okay, and that's scale factor 2. But as much as the description doesn't suggest you can also do smaller scale factors. So we can do a scale factor of a half, scale factor 0.5, where am I going to fit it? Scale factor a half or 0.5, and that will be, I don't really have squares small enough, but you get the picture. Every side, remember on these ones, every side is double, every side is triple the original object, every side is halved. Okay, don't think about the area and stuff, just think about the sides. Each side length will be half of the original object, okay? And that's the basis of enlargements, but you will be given a question where you have a center of enlargement. So you can't just draw this, I just drew this wherever I liked, and this one just drew it wherever I liked. But you will be given a center of enlargement, COE. I mean, they'll call it center of enlargement, don't get me wrong, but we abbreviate it a lot. Center of enlargement. Now look, these 3 are lined up rather magnificently by accident to illustrate the point. Enlargement with a center of enlargement is like you have to imagine a torch. Damn, it's not quite going to fit. That's a shame. I could probably move. So imagine a torch behind this. So your torch is coming over here. I don't know what a torch looks like that, and then like that. Okay, there's some buttons, and then it's shining a light. Okay, and so the object here is there. Imagine, you know, when you're putting your hand in front of a torch, and then it shines an image, which is of course bigger. Because this object is closer to the torch, so it shines an image, and that's kind of what the center of enlargement is where the torch is coming from. So there's 2 ways of looking at it, and I'll just show you both and you can decide which is better. So we've got some axes, and it'll always be on an axis, these questions, and it'll say center of enlargement -3, -2. Let's go a bit further out, -4, -3. And we want to do a scale factor of 2. Again, that's all the information we need. We need the center of enlargement, -4, -3, and the scale factor. Okay, so, and because it's recorded, it's fine. You can copy this down, pause the video, because what I have to do is I'm going to have to undo, and then I can do a different example on the same grid. So, just thought I'd point out, by the way, this is fine doing this, not labeling each interval, as long as you're starting at 0 always, and you're going up equal amounts each time. So I'm going up 1, 1, 1, 1, 1. But you don't have to label all the numbers if you're feeling lazy. -4, -3 is there along the corridor up the stairs. Now, the first way I'm going to teach you to do it, because that's the way everyone seems to prefer it, is first of all I'm going to work out how to get to each corner of this shape. Remember, we deal with the vertices, not the whole shape, from the center of enlargement. So you can see here that I go right 2 and up 2, okay? And that is just to the original object. So this serves as if it was scale factor 1. So the original is scale factor 1, okay? Should be an I in there. Okay, so guess what you've got to do from the center of enlargement if you want to do a scale factor of 2? You've got to double it. So instead of going right 2, you go right 4. Instead of going up 2, you go up 4, and that will be this vertex on the image of the new shape. Okay, now I don't know what you prefer, whether you want to go 2, 2, and then do it again, because then you can think of it doubling. So we do it once, do it twice. If we did a scale factor of 3, do it 3 times. I think it seems more logical to do it in one go, but it's entirely up to you. Whatever works for you. Get the same answer, of course. I'll try and do this in, so scale factor 2. So it's going to get a bit hickory-pickory in here, a bit of a mess, but I'm going along 2 and then another 2. So I've gone along 4. And then I'm going up 4. Without counting 3, 4, up 4. And so this corner corresponds to this corner. Okay. And then again with translation, I told you could just draw one corner, plot one corner and then draw the rest of the shape. You can do that with enlargements. It's risky with other transformations, but we know that each side is going to be double. The orientation will stay the same, meaning it's the same way up. This bottom side is 2, so this will be 4. This is 4, so it'll be 8, etc., etc. But I'm going to show you anyway, doing it a couple more corners perhaps. The trouble is it is going to get messy, and these corners are going to go off the axis grid. So how about I do this vertex? So purple. So to get there originally, do I want to do this bit in purple? Guess so. So I'm going right 4. And I'm going up 3, okay, to this corner. So in order to do a scale factor of 2, I've just got to double it. So instead of going right 4, I'm going to go right 8. And instead of going up 3, I'm going to go up 6. I've kind of run out of colours. I've got loads of colours. Bit of glittery. No. Orange. So I'm going to go, so what did I say? We're going right 4, up 3. And it's purple, wasn't it? Right 4, up 3. So I'm doubling that. So I'm going right 8. Oh, I don't really want to mark that. I often do mark it as my sort of the point on the way to where I'm going, but I don't want to confuse you. So that's not our final. But we're going to turn here because I've gone right 8, which is double the 4. And then I'm going up 6, which is double the 3. 1, 2, 3, 4, 5, 6. I'll just double check that before I draw the rest of the shape in. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Lovely. 8 to the right, 6 up, because I am doubling. I'm basically doubling because it's scale factor of 2. So we can colour this in now. Let's do one final colour, a nice electric blue. So as I showed you before, what we can do is we can say, right, this corner has gone to here. It has been transformed from here to here. So I could just draw the rest of the shape in. It's double. So the bottom side is going to be 4. This side will be 2 because it's doubled. This side 2. This side 6. I definitely run out of space. 2, 3, 4. Keep going. And then this one up here, approximately. and you will see it probably ask us to label it A apostrophe or B or something. But this side is double, this side is double, this side is double. Now, what I want you to notice is this torch scenario. So, again, better at using this ruler, but not the best. If we line up, look, the center of enlargement with a with any of the vertices of the original object. And let's perhaps try one that we didn't work out. So we did this one, didn't we? And we did this one. So let's do the bottom right hand corner just to check this method works. Because this is a slightly different method. It's the method I prefer, but for some reason students don't seem to. So it might not line up perfectly. That looks pretty jolly good, doesn't it? And we can draw what we call ray lines. So imagine the torch is coming out of here. Oops. I'm going. Okay. And then you will see that whatever distance this vertex is from the center of enlargement. So, I mean, you would use a ruler rather than counting. It's because it's kind of 4 diagonals across squares, but they're not 45 degrees, so it's not really that. That's why probably it's easy to think 4 and 2. But if you measure that with a ruler, this corner will be exactly double the distance from the center of enlargement as this. Okay, so even if you don't use this method, it's a jolly useful way of double checking your answer. Because if we do that on any of the corners, or all of the corners, the vertices, it will hold true. There and there, it seems to be slightly missing there and there. Cool. And of course, there's a bit of accuracy lost because I'm using an online tool, so I've slightly missed there. But if you've got this written in your book, you will see, and if you've marked the points right exactly where they should be, they will perfectly cut through. And these are called ray lines, and they're like a torch, aren't they? So basically, what you do is you count the squares from the center of enlargement to the object, so the object that you want to transform. And then if it's scale factor 2, you double it, scale factor 3, you triple it, etc., etc. You can either use these ray lines to check your answer. I mean, look how easy, if you had this written down on paper in front of you, how easy is it just to place a ruler there and go boom, boom. Okay, is that double the distance? This corner from here to here, call it 15 millimeters. So this should be 30, etc., etc. Okay, they're called ray lines. So that's the alternative method. But I do just want to, so copy that down, please. I'm going to backtrack. Always risky.